have the following. It says segment MP, excuse me, let me make sure I get started here. Segment MP and segment LP are angle bisectors. So I know these two things are true for triangle LMN. It says find the distance from point P to segment MN. Now remember, that means point P because these are where the two angle bisectors intersect. Point P is the incenter. And what did our last page say about that? It says the incenter of a triangle is equidistant from, make sure it says from there, the sides of the triangle. That means those would be all the same. Now that's the perpendicular distance. That means if I drop this straight down, I dropped it straight down this way, all three of these segments, I'm going to do it big red here, the segments are going to be the same length. So what is the distance from point P to MN? Well, here's MN. They're all the same. If that one's 5, that one's 5. So the length, the distance, I'll do it this way, is 5. That's all you have to do. So just need to memorize it and be able to work with those. We'll do some more problems when we're working on the homeworks together. All right, we have another new term. This one is a loaded vocab section, but this one makes sense. What do you call when you're driving down a road, let's say, and it's one of those 4-lane highways that's divided? What's that section called? Yeah, it's called the median. Well, we're going to have a median also of a triangle. So use that kind of definition with it. A median of a triangle is the segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. Now, because there's 3 angles, there's going to be 3 medians, but look how it's drawn. Vertex to midpoint. Please hear me on this. Angle bisectors don't have to be medians. Medians don't have to be angle bisectors, but a median will always go to the midpoint of the opposite side. And remember, every triangle has 3 medians, and those medians, obviously because they're always drawn in the middle, are gonna be concurrent also. Now when we work with those, we have a name for those also, and that is called the centroid. I love this one. Okay, so the median means middle, centroid means like center, so doesn't that make you think of kind of how you can memorize it? So the point of concurrency of the median of a triangle is called the centroid. Now, I haven't finished drawing it out, but let's draw the other medians. All right, so it's the centroid of the triangle. Make sure we knew that. Medians, centroids. So let's draw the median here. I'm going to go to the midpoint of this side, and I'm going to go from the vertex to the midpoint of the opposite side. There it works. Now if I get about the midpoint of this side here, I'm a little bit high, about right there. Again, I can eyeball it. I'm doing this enough years. You should know, it's about as rough as I got it. This point right here is called the centroid. Now here's the cool part about a centroid. If you were to cut out that triangle and balance it on a tip of a pin at the centroid, that's its center of gravity, it will keep its balance. That to me is like the coolest physics thing ever. All right, and we talk a lot about center of gravity in athletics and sports for like how you move, how you can use your energy more efficiently. I remember talking about this with my coach when I was trying to learn long jump. It helps me move. All right, we're going to go to the next page again to finish working a few more examples. We just have a couple more pages of notes. This is why this is a 2-day lesson, so we can make sure we really understand it.